Assalamu alaikum. My name is Habibullah 21TE79. Today we discussing digital signal processing lab number 6. Uh, First we see the lab manual. In lab manual, the lab objective is representation of discrete time digital signal into frequency domain by FFT, resolution of spectrum, computation of magnitude, phase and power spectrum, spectrum leaking and avoiding spectrum leaking. Now moving towards task 1. In task 1, write a MATLAB program to validate the above given decimation. Program first divide the given signal into even and odd sample, then calculate DFT for even and odd sample separately and then merge both of them using formula. Now we'll go to the PDF and see the task 1. So this is the source code. Task 1. The given signal is x is equal to 1, 2, 3, 4, 5, 6, 7, 8. Then decimation factor is m is equal to 2. Then divide the signal into even and odd samples. X of e equal to x into 1 and then end. Then x odd. Then calculate DFT for even and odd samples separately. So NE is equal to length, N odd length, and GE is equal to FFT into XE. GO is equal to FFT XO. Then merge both of them even and odd signal. Then use for loop using formula. Then in the last we display all the result. Display original signal, display decimated signal, then display reconstructed signal, display inverse FFT of X. Then this is the output. The original signal is 1, 2, 3, 4, 5, 6, 7, 8. Decimated signal is 1, 3, 5, 7. Because of m, we take decimated signal m is equal to 2, and then reconstructed signal is this. So this is all about task 1. Now moving toward task 2. In task 2 says check the above program for a signal given below. There is x1 to x8 and all x have some value, and the last says that observe and find any symmetry in frequency representation. Also match the calculated DFT with standard function of MATLAB. Let's see in the PDF which we solved already. This is the source code. Given signal is x1 is equal to 2424. Decimated factor is m is equal to 2. And divide the signal into even and odd samples. X is equal to x1, and we take a limit of this 1 to 2, and x odd is equal to x1, 2 to 2. Then calculate DFT for even and odd sample separately. NE is equal to length, and O is equal to length XE and X naught XO. Then GE FFT XE, GO FFT XO. Then merge both these signal even and odd. Then use for loop with the formula. Then we display the result. Display the original signal. Display x1. Display decimated signal. Display inverse of FFT of x. Then compare the DFT with standard MATLAB function. Display DFT of x1. Display FFT of x1, and display DFT of decimated x1. Display x. Then we get an output. This is our original signal 2424. Decimated signal is 333. DFT of x1 is 12, 0, minus 4 and 0. And DFT of decimated x1 is 12, 0, 0, 0. This is all about task 2. Now moving towards task 3. In task 3 says check the program in task 1 for a signal given below and compare it with standard function x and y. Both signals are given. Now we move to PDF which we made. Here is the source code of task 3. The given signal which was given in the manual, x and y. Now we defined a decimated vector m is equal to 2. Then divide the signal into even and odd samples like previous. Then calculate DFT for even and odd samples separately like previous. These all. Then use for loop with the help of formula. Then display the original and decimated signal. Display original signal x, display x, display decimated signal x, display IA50 x, display original signal, display y, then display decimated signal x, display IA50 of y, then compare DFT with standard MATLAB function, display DFT of x, display F50 of x, display DFT of decimated x, then display of x, display DFT of y, display F50 of y, display DFT of decimated y, and display y. As a result, we get an output like this. This is original signal, decimated signal, decimated signal x, DFT of x. That's all about task 3. Now moving towards task 4. And task 4 says we can further subdivide the above decimation up to 2 samples and calculate the DFT of 2 sample. Then 2 sample DFT add to form 4 sample DFT and 2 4 sample DFT from 8 sample DFT and so on. This point is made, it's called radix to fast Fourier transform algorithm. Write a program myFFT that transfer a given signal into a frequency representation using radix to FFT algorithm. Now moving towards PDF, the source code. First we define a function x is equal to myFFT, then define length, then n is equal to 1 and x is equal to x, and return. After this, divide the signal into even and odd samples like previous, then merge the DFTs, x is equal to 0 into 1 and n, then use for loop. The input signal is given, then calculate frequency representation using F50 function, which is x is equal to myF50, then compare with the standard MATLAB function, then display the result, display myF50, display x, display MATLAB F50, display x MATLAB. Now we get the output. This is the output. This is all about lab task 4. Now moving towards task 5. In task 5, says calculate the fast Fourier transform using your own function. Task 4 and compare it with the standard function of calculating DFT as following for the following signals. There is 4 signals x, w, x, y, z. Moving towards PDF is the source code, the defined symbol which was given in the lab manual, w, x, y, z. Then calculate the FFT using custom function for all these, and calculate the FFT using a standard function which is written here, and compare the result. Display result of my FFT compare with FFT, display signal y, display custom function, and display standard function, display signal z, display custom function. As a result, we get an output. This is the result of my FFT compare with FFT, signal y. So custom function is this and the standard function is this. This is for y and this is for z. Custom function this, and the standard function this. This is all about lab number 6 of digital signal processing. Thanks for watching.